Right now, an invisible ocean of dark matter is still flowing through your body, through every wall, every mountain, every ocean on this planet. And the sharpest minds at MIT, Yale, and CERN have no way to stop it, slow it, or catch even a single particle. But here's what nobody is telling you. They think they finally know what it's made of. For almost a century, physicists have known something is wrong. The galaxies we can see, the stars, the gas, the dust, they move as if something invisible is pulling on them. Something heavy, something everywhere. They called it dark matter. And it makes up 27% of everything in the universe. We live inside it. We pass through it constantly. But we have never once touched it, measured it, or confirmed what it actually is. Until now, the most popular candidate was something called a WIMP, a weakly interacting massive particle. For 40 years, experiments buried under mountains searched for WIMPs. Underground labs in South Dakota, tunnels beneath the Italian Alps, they found nothing. Every major WIMP detector came up empty. And that failure, quiet, expensive, humiliating, sent the entire field in a new direction. They started looking for axions. An axion is a particle so small it barely exists in any useful sense. It is billions of times lighter than an electron. It doesn't emit light. It doesn't absorb light. It passes through lead, through steel, through the entire planet Earth as if none of it is there. If axions are real, and a growing number of physicists believe they are, then right now, in the space between your fingers, there are trillions of them. Here's what's strange. Axions weren't invented to explain dark matter. They were invented to fix a completely different problem, a crack in particle physics called the strong CP problem, a flaw in how matter and antimatter behave that has never been fully explained. But the math that fixes that flaw produces a particle that just happens to match everything we know about dark matter. The mass, the behavior, the invisibility, it fits too perfectly to be coincidence, and that is what has physicists nervous. The problem is catching one. To detect an axion, you need a magnetic field strong enough to force it to convert into a single, faint photon, a flash of microwave light so weak that literally any vibration in the universe will drown it out. The detector must be cooled to within a fraction of a degree above absolute zero. The equipment must be shielded from every stray electromagnetic signal on Earth. And even then, you're listening for a signal so quiet it barely registers as real. The experiment in Seattle called ADMX, the Axion Dark Matter experiment, has been running for over 2 decades. It has not confirmed a detection. Neither has HAYSDAC at Yale. Neither has Abracadabra at MIT. Every null result narrows the search, but nothing has been found. But here's the strange part. It shouldn't be possible for us to have missed it this long. If the axion is real and makes up the dark matter we've measured gravitationally for decades, then our detectors should have found something by now. The models say the signal should be there. The math says we're looking in the right range. And yet silence, which means one of 3 things is true. Either the axion exists in a mass range we haven't scanned yet, and we are simply 1 year away from the biggest discovery in human history. Or it exists but behaves differently than theory predicts, and we don't fully understand it yet. Or, and this is the possibility that keeps certain theorists awake at night, dark matter is not axions at all, and we have been chasing a ghost for 40 years. That third option is the one the field doesn't like to discuss. Because if axions don't pan out, there is no clear next candidate. The WIMP era is over. The axion era may be narrowing. And the uncomfortable truth is that whatever dark matter is made of, it was apparently designed, if you'll allow the word, to be as difficult as possible to detect. Not because we're looking wrong, but because it barely interacts with anything we know how to measure. Think about what that means. 27% of the universe is made of something we cannot see, cannot touch, and cannot identify. It holds galaxies together. It shaped the large-scale structure of everything that exists. And after a century of searching, we still don't know what it is. The axion hunt isn't just a physics experiment. It's a test of whether human instruments will ever be sensitive enough to reach the fundamental fabric of the universe. If ADMX or HAYSDAC or the next generation of detectors confirm the axion signal, even faintly, it changes everything. It proves the universe has a hidden layer of physics we've only glimpsed in equations. It opens a door to cosmology, to our understanding of time itself, sealed since the Big Bang. A single photon converted from a single axion would be the most important measurement in the history of science. But here's what they're afraid to say out loud. If we find it, if that signal finally appears, we'll know what the universe is made of. And that will immediately raise a question nobody is ready to answer. What else is out there that we still can't see?